Hi everyone and welcome to our Coolest Projects Advanced Programming webinar. We're really excited to have you here today, and we're going to be doing some great stuff with code to get you making some incredible advanced programming projects all ready for Coolest Projects. I'm joined today by Diane. Hello. Who's going to take you through a really fun project with some great code, looking at some fun things you can do with space. But before that, I just want to give you a little reminder of what Coolest Projects is, what we're here for, and how you can get involved. So, quick reminder, what is Coolest Projects? We are a celebration of young people and the amazing things that you make with code. Coolest Projects is open to any young person up to age 18, and we have a couple of different ways you can get involved. One of them is our big online showcase. So this is our big annual online event for young people anywhere in the world, any country. And we have a great showcase gallery where you can share your projects. And if you get involved, you get certificates and feedback on what you have made, as well as a really fun live stream celebrating all of the incredible projects. Last year, we had over 4,000 projects from over 7,000 young people from 43 countries. So Coolest Projects really is global, and we encourage absolutely everyone to get involved. And we also have some great events in person as well in some countries. You'll find all of that information on our Take Part page, which is down below at the screen at the moment. Take a look at the in-person events that we have open. Get involved in those. And registration is open right now, is my main point. So if you want to participate in Coolest Projects, now is the perfect time. So how does it work? Any young person can get involved, and you just make a digital project, and that can use any kind of hardware or software. You can submit your project individually or in teams of up to 5, so code along with friends. And we've got 7 categories. So whatever you've made with code, there is a home for it, Coolest Projects. Today, we're going to be focusing on advanced programming. Now, you can make something new, like in our webinar today. We've got great ideas for you. Or you can share something that you've already made that you're proud of, and there's a great opportunity to get feedback, certificates, rewards for participating. Here are all the fun events that you can get involved with. So registration is open right now. Our online showcase registration still is open until the 28th of May. And if you are in the USA, Belgium, the UK, Ghana, Sri Lanka, Nigeria, Hungary, India, Malaysia, South Africa, so many places across the world, you can get involved in an in-person event too. All the information is there. We also have, and I would encourage everyone to have a look at this, no matter what kind of project you want to make, we have an online showcase gallery that is open for 2025, and we're already starting to see some amazing projects come in. So you can get involved and have a little look at what people are making already. And I just pulled up a couple of advanced programming projects from 2024 gallery here to have a look at, to just show the really diverse range of reasons, ideas, inspiration behind some of the projects that people make. So we've got Andrew in the UK who made Breadcord, which is an incredible project. And he said, I aim to encourage people to self-host, assemble, tinker with their own bots, and learn some programming along the way. We met Andrew last year at our UK event. He had some incredible coding skills, and his motivation is really sharing that with others to make it accessible and get everyone involved in the joy of coding. And then I also have a quote here from Hiba, who participated in Coolest Projects Online in 2024 and made a really fun assist bot. So it's a service and companion robot for lonely people, elderly, those who are often stuck at home. And she was inspired by her grandfather, who had a stroke and was often home alone. And she wanted to create a really specific solution for him. And so she used her amazing making skills to solve a problem that mattered to her and her family. So as you can see, there's loads more of these online, but there are loads of reasons you might want to make a project, get inspired, start something new. And that's exactly what we're going to do today. So I'm going to hand over to Diane, who's going to get you started making some really fun advanced projects today.
Thank you, Helen. That was a great introduction. So welcome to the coding part of this event. Today we're going to have a couple of, we're definitely working towards an advanced project, but clearly setting out to do an advanced project, if you're not very confident, can be really intimidating. So what we're going to do is we're going to start with some quite simple coding, and then we're going to look at how we can extend that and make it more advanced. And ultimately, it will be entirely up to you how far you can take this. So hopefully it will inspire some ideas. And our starter project today is called Who's in Space? And why is this cool? Well, I suspect that many of you, like me, think space is really cool. I'm really fascinated by all things space. I love a rocket launch. We're going to use some real data from an API. And if you've never used an API before, I'll talk about what that is in a moment. It's a really good way of getting some data for your projects without you having to make up data. And getting real data is always way cooler than making up test data yourself. So we're going to have a look at how to use an API. And to do this, if you're going to follow along, you will need, well, you'll obviously need a computer. We're going to be coding in Python. Again, my aim today is to try and make those of you that have just done a bit of Python coding feel a bit more confident to extend that coding into an advanced project. I'm using Python 3. You do need a library. I'll show you the details of this in a moment again. I've managed to do it so you only need one library. And we're going to give you some instructions as to how to do that. And you will need access to the internet because we're going to be taking live data. So let's have a look first of all what an API is, and then we'll have a look at how we're actually going to use it. So as you can see on the screen, this is like a lesson, isn't it? An API is an application programming interface. And basically it's just a set of rules that enable you to work with a web server to get some data. So we have to have the rules because we have to know how the data is laid out and how to get it. And basically in our application, we make a request to the API for some data, and the API sends it back to us. There are lots of different types of API, and if you are a fan of social media, you'll find there are APIs that allow you to work with things like Facebook and Instagram, or whatever you cool kids are using at the moment. But today we're going to use a web API, and specifically we're going to use Open Notify. I'll show you that in a moment. So to get started, you will need to install the requests library, and you can see a short link to some instructions for doing this at the bottom. If you do it on your computer at home, you shouldn't have any problems with this. If you try to do it at school, you may well have problems because school IT departments never like you installing things. So I do suggest that you try to do it on your own computer. We've given you lots of instructions there, so hopefully you will be able to do this. Otherwise, a Google might help you if you get stuck. So once we've installed our request module, then we can write some code. And I am going to switch to some live code in a moment. But first of all, I'm just going to show you the amount of code that you're going to write. And hopefully you can see that this is not an intimidating amount of code. Okay, so we don't have that many lines. In fact, 4 of them are comments. So what we're going to do is I'm going to take you through these bit by bit, and then we're going to switch to a live coding window, and I'm going to show you what should happen when you run your code. So this is what we're aiming for. You can see here we're going to write one function. It's called people in space. And then at the bottom, we're just going to run that function. So everything's in one single function, first of all, and let's take you through it. Oops. Spoiler alert there as to what was going to happen. Okay, so right at the beginning, our first lines of code then is to define the function. I've called it people in space. I suggest you keep the names the same as I've used because it will make your debugging a little bit easier. And you can see the very first thing we're going to do is we're going to make the request to the API. So you can see here, here on the screen, that we do this, we write this command here, request.get, and we send it the URL of the API that we're trying to contact. And you can see here, it's called opennotify.org. And particularly, we want this set of data here, which is a list of all the people who are in space at this precise moment in time. Now, how cool is that? So we're going to send it the request, and it's going to send us back the names of everyone in space. Fortunately, there's nearly always somebody in space, because the space station is nearly always got people on it. So we should always get somebody back. And if it's a bit more exciting, we might find there's other vehicles, manned vehicles in space at the moment as well. So we first of all make the request, and then what we're going to do is we're going to get the data back from the request. And when we get that, if we print it out, what you would see on the screen is, as you can see at the bottom here. So the data is returned to us as a JSON file, and a JSON is a really standard format for exchanging data between a server, between a client and a server. It's a standard format, so most programming languages will be able to handle it. And when we do this, when we type this command into our program, it will take that JSON file and it will convert it to a dictionary in Python. You may or may not know what a dictionary is. It depends on the level of your programming skills, but a dictionary is a data structure, and it's a data structure in which data is held in what we call key value pairs. And we can see an example here of a key value pair. Here the key is the word craft and the value is the word ISS. So I said, first of all, that data looks quite scary, lots of curly brackets and things like that. But what we can see here is that actually we've got, first of all, a list of people. Okay, and then we can see it's a list here, because if you code in Python, you can see the square brackets here. And if we go along a little bit later to the end of the square brackets, because all of these here are our people, then what we have is the number of people, which is 12, and a message, which is the end of the JSON file, that said our request was a success, which is good. Okay, now inside our list of people, basically we have sets of information for each person. We have the name of the craft, this instance the ISS, and the name of the astronaut, which in this case is Olin Kononenko. I wish I hadn't picked that one. That was really hard to pronounce. Okay. Further on, we can see that actually at the time I ran this, there was another spacecraft. There was the Tiangong spacecraft, which I believe is a Chinese one. And you can see there were 3 astronauts on that as well. So actually we can see immediately the information that we're going to get back into our program. Obviously, the information you get back will be different because you're running it on a different day and there may well be different astronauts out there. Okay, so yeah, I've talked through that. So our next line of code then is, first of all, we're going to display the number of astronauts. And what we're going to do here is we're going to take our data that we've extracted from the API, and we're going to use that key number, and that will get us the number of astronauts. So this is the one that you really want to concentrate. We're going to access that set of data. We're going to use the key number, and the value that is returned, we're going to assign to number of astronauts, and then we're going to print them out. We're going to use an F string here because it's a really nice way of inserting a value into a print statement. And just for fun, we got a little emoji rocket at the end of the print string. And most terminals will print that out. So hopefully you'll get that printed out. Otherwise, you'll just have to ditch it. Okay. And then we're going to display the astronauts. Now, as we saw earlier, the astronauts is a list of data. So we haven't just got one astronaut, we've got a whole list of astronauts. So we're going to use a loop here to work our way through that list. And for each astronaut, I'm going to pull out the name of the astronaut and the craft that they're on. And then I'm going to print out, again with a cute little emoji, that this person is on this particular spacecraft. And we can run through that and we can work our way through. We'll print out each one at a time. So now that we've finished our program, we can have a go at running it. So I've got it loaded on the screen in front of me. I'm just using the standard Python idle here. So let's have a go at pushing the run button and see what happens. Yeah. And here are our results. Sometimes it takes a little bit longer to run because sometimes there's a bit of a delay in terms of the server responding, but you can see here the results are exactly what we expected. We've currently got 12 people in space, and we can see the names of each of the 12 astronauts together with the craft that they are running on. So far, we've written one small program that's contacted an API, got some cool data, and we've processed that data to display it in the console. And one of the things about a console application is that they don't feel very cool because it's just a load of text. So you can jazz them up a little bit. So you can use emoji characters. So most terminals will support emojis. You saw earlier that my Python idle, I was just using the standard idle, that would display the emojis. You can just include them in your print statements, as I showed you previously. You can also use Unicode symbols. So if you have a look at Unicode online, you'll find there are thousands and thousands and thousands of symbols that you can use. So you can feel free to go haywire with those. And you can also do ASCII art. And ASCII art is much loved of many people. This is where you create images just using really simple ASCII characters. And we can see here that this rocket is just made up of backslashes, forward slashes, and some lines and underscores. Notice here on the right, we've got this double backslash, and that's because backslash means something in a print string. So to actually get it to print a backslash, you have to do it twice. Okay, but have a little experiment with that. It can certainly make your console programs much cooler. Okay, so we're now going to move on to an advanced project, and we're going to have a look at an ISS tracker. We're actually going to use the same Open Notify system. They have another API to get the position of the ISS, but this time we're going to make a visual interface. So rather than a console system, we're going to make a nice window with a map on it. You do need a couple of libraries, but fortunately you don't have to install them. They're standard Python libraries and you should have them. And the other thing you're going to need is an image of the world map. And I think we've got a short link for this for you as well. I used a copyright-free NASA map, which works really well. So I'm very, very pleased with how this works. I took a screen grab of it and I resized it to 1000 pixels wide. If your image ends up with a different dimension, I'll show you how to do the scaling, but you'll need to scale it slightly differently. And the really important thing here is you must save the image in the same file as your Python folder. Okay, so we're going to start out then by writing some code to display the map. And we're going to use Tkinter here. Tkinter is the standard Python GUI, graphical user interface. It always looks like quite complicated, but it's not really complicated. And I'm trying to use here as few commands as possible for you to actually get something that works on the screen. So if we have a little look at the bottom, we're going to make a window. We're going to call this function here called display map, which will actually put the map on the window. This line here is just going to put it to the top of the screen so that we don't have it hidden behind all of our code windows. And main loop, whenever we're writing a screen program, it runs in what we call an event loop. And this is so that if you do things on the screen, like press the escape button or move the cursor or something like that, that some of these actions can be picked up. So this is standard code for Tkinter. And then we've got this little line here. So we're going to set up the window. I've given it a title here called My Cool ISS Tracker. You can give it whatever title you like. I've made the window the same dimensions as my image. That just makes it really easy. Okay, so these are the dimensions of my map. This line here just positions the canvas on the screen. I then make this thing called a turtle screen. I'm using the Python turtle module to actually make the ISS icon. It's not a turtle, it's just a dot. And finally, I'm putting my map onto the screen. Now, you could run the code at this point, but you won't see anything other than a white window because at the moment we haven't actually drawn anything on the screen. This is just a background. Okay, so we're going to write another function now, and this function is going to get the location of the ISS, and we're going to get this using the API. So just like you did before, you're going to use the same request.get, but now you'll notice that we're using issnow.json. Previously we got the astronauts. Again, exactly the same here. We get the data from the JSON file, and here we're going to extract the ISS position. This is actually a really simple bit of data. It just literally gives us the latitude and longitude of the space station and the little message that says success. And then from this, I'm extracting the latitude and longitude. So from the ISS position, which is 2 values, I'm taking the first value, which is the latitude, and the second value, which is a longitude, and I'm converting it to a float because it's a string value. So for me to handle it numerically, I have to convert it to a float. And then this function is going to return those two values. Okay, so you can write that one just as is. And then finally, you're going to write some code to display the ISS on your map. Now, we have to do a little bit of maths here. So we take the coordinates from the function that we've just called, and here we're going to scale the coordinates for the map. Now, we have to do this because the size of the map will distort where the coordinates end up. So basically we've got to scale them for the map, and I'm going to talk you through that in a moment. But this is what these two lines, they're quite simple. These are my scaling factors for longitude and my scaling factors for latitude. And then finally, we're going to use the turtle. We use something called raw turtle because we're not using native turtle, to create an icon for the ISS. I put the pen up so it doesn't draw lines all over the screen. I then go to my XY coordinates, which are the ones I scaled earlier, and I'm going to make my little blob a yellow circle, and this is the size. You can go, you can go crazy with this. You can make it whatever sort of shape and size and color that you want. Okay, and then we're going to add that code to the end of our display map function, and now when we run it, we will indeed see the ISS. So when you finish writing your code, you will need to test it. So here I've got my completed program on the screen. So you can see I've got two functions. The first one, which gets the coordinates of the ISS by making the call to the API, and the second one that handles the display of the information on the screen. So remember, I'm using Tkinter here, just making a really simple window that uses a canvas and some of the functionality of Turtle, and basically sticks the map on as a background, gets the coordinates, scales them, and then positions it as a yellow circle on the screen. Remember, you can and should customize any of this, build on it, make it even cooler than my copy. So what I'm going to do now is I'm going to run my program. So let's run the program. I'm just using the standard idle here. And here we can see that my call ISS tracker, and we can see that it looks like it's just gone over the end of Turkey by the looks of it. And one of the things that we can do is we could compare this to a more professional tracker. So I'm just going to look on the internet now. I've got one bookmarked. We'll compare where we've got the space station with where it is according to another app. So if I just pull this one up, just going to minimize mine. And again, you can see here, yeah, super. More or less in the same place. So just gone over Turkey. So that's great. Interesting, this particular app also has the current position of the other space station, the Chinese space station. So maybe that's something you could do. You could make a tracker for that. You could even have them both tracked on the same map. You can see that currently the Chinese space station is over the Atlantic Ocean. So you could have a go at that as well. Put them both on there, different colours, that would be fun. Okay, so just talk a little bit more about the scaling. So as I said, the ISS position is given in latitude and longitude. And in real life, latitude, which is our north-south dimension, ranges from minus 90 degrees to plus 90 degrees. And our longitude goes from minus 180 to plus 180. Our world map is obviously a flat image. And mine's 1,000 pixels wide by 485 tall. So what we do here is we just use a really simple calculation to scale those factors. And we just take the width of the image and we divide it by 360. That is the range. We're going to go from minus 180 to plus 180. And for the latitude, I go 485. That's the height of the image. And again, I'm taking the north-south. It goes from minus 90 to 90, which is 180. So if your image is a different size, you need to use the different values here. You need to substitute them and you'll get slightly different scaling factors. So if your space station doesn't end up in the right place, it's almost certainly because you haven't got the right scaling factors. So that's one thing to check. Okay, now hopefully you think that was a really cool project. I thought it was a really cool project. There are ways you can make it even cooler. So let's have a think about what you might do next. So taking the first project, the list of astronauts, you could superimpose those on top of the map. So as well as showing the location of the space station, you could somewhere on the screen show a list of the astronauts. If you're really smart, you'll make sure they don't overwrite each other because you don't know where the space station is going to be. So you could check, make sure your list is in a different place. Even cooler, obviously, is to get the tracker to update. So currently, it just shows the current position, but we could call the API. I suggest you do it about every 10 seconds. If you do it more frequently, you may get your API access blocked. That happened to me when I was testing this program, and I had to wait about an hour before I could run it again. So when you're testing, I'd make it even less frequently. It does mean you have to wait a little while for the screen to update. You could get the application to send you a notification. I think that would be really cool. You could get it sent you an email or a text message. Again, you'll need another library to do that. And finally, you could use another couple of APIs to get more information. So you could get weather information. It'd be good that you didn't run outside if it's raining, because there's no point. You could also get the sunrise and sunset times. Again, no point running out to look at the ISS at the moment because it's broad daylight here. So I hope you like those ideas. They're really fun things that you can do to develop this project. So good luck with your coding, and I'm really looking forward to seeing your advanced programming projects in the Coolest Project Showcase soon.
Thank you so much, Diane. That's an amazing project. Love the step-by-step guides, and it's definitely something that you can develop in all these different ways. So it's the perfect project for Coolest Projects. So thank you so much for sharing that with us. I'm just going to close out today by reminding you to enter. So you can use this code along to make an incredible project like Diane's just shown you, but you could also, if you want more inspiration, have a look at our project site. So projects.raspberrypi.org is where you need. And we have, I think we're in the literal hundreds now. We've got so many projects there that offer the same step-by-step guidance. So if you want to make this, if you want some different ideas about how you could expand it, take a look at the project site to get some more ideas. And also, if you have any questions, please do get in touch. It's hello@coolestprojects.org, and I'm the person behind the inbox. So if you have any queries, please just send us an email, let us know, and we'll do everything we can to help you participate. And we really just want to encourage you to enter your project to the showcase. Registration is open right now. We want to see what you've made at events and online, and it's been lovely having you all today. Thank you so much, and goodbye.